Hey, welcome back to Mr. Nelson's class again. We're talking about chemistry. In this case, stoichiometry. Your favorite. I know it is. Okay, we're going to do stoichiometry mass to mass. We're going to use practice sheet number 5, problem number 1. And if we read the question, it says using the following word equation, sodium hydroxide reacts with sulfuric acid, creating water and sodium sulfate. And well, how many grams of sodium sulfate will be formed? That's what we're looking for if we start with 200 grams of sodium hydroxide. And just remember, you're going to have an excess of sulfuric acid. And this is going to be a theoretical yield. So let's go ahead and start off with the first thing that we have to do is we have to find the skeleton equation. So we have to use our rules of nomenclature to figure out what are the formulas for the compounds that are in the equation. So we have sodium hydroxide. Now, one thing about sodium hydroxide, sodium hydroxide, we look at it, we have a metal and we have a polyatomic ion, which means, and there's no Roman numeral, which means that this is a type 1 compound, but it's also polyatomic. So sodium is a +1, and how do we get +1? Well, it's in column 1A of the periodic table, which means it has one valence electron, and it will lose that valence electron, which is a negatively charged, and become a +1. Hydroxide, the way that we're going to find the answer for that is to look at our chemistry packet, go to that last page, find hydroxide. You'll notice that it's OH and it's a -1. So it's -1. Since they already cancel each other out, we just need to know that we only need one of each one. So I'm going to come down here and I'm going to put in our equation. So we're going to have NaOH, so sodium hydroxide, and that's the formula for that. It's going to react with sulfuric acid, and all acids begin with H. Now the big thing is I look at sulfuric. Ic means I go back to 8. I find sulfate on your polyatomic ion sheet, and sulfate is SO4. But what's the charge? It's a -2. So if I have a -2 for my sulfate and a +1 for my hydrogen, that means I have to have 2 hydrogens for every 1 sulfate. Okay, and so that's how we come up with that one right there. Okay, now when those react, they're going to create. Okay, so they're going to create or yield to water, H2O, which hopefully we know the formula for water. It's a type 3 compound. So if we had to name it, it would be dihydrogen monoxide. And what else is going to be left? Sodium sulfate. Well, sodium, let's just go right over here. Sodium is going to be a +1. But what is sulfate? We already said it over here. It was a -2. So that means we do have to crisscross. And so when we add this in here, we means that we're going to have 2 sodiums. So we're going to Na2 and 1 sulfate, which is SO4. And when we get all done, we're going to end up with our molar ratio, and you need to make sure that you show that. So our molar ratio is going to be what it has once we balance it out. So how do we go ahead and balance it? We're going to go ahead and write down what we have of each one on each side. Remember, if we have a polyatomic ion on both sides, we probably should keep that together. It works out most of the time. So we're going to have Na. Now I have polyatomic ion of hydroxide here, but I do not have it on the other side. Okay, but I'm going to also just put it over here. So I have sodium over here, Na. So I'm going to have oxygen on each side, and I'm going to have hydrogen on each side. And we have our sulfate right here on this side, so SO4. And we'll put our sulfate there. Okay, so how many do we have on each side? So if we look at our sodium here, I look down, I have 1 sodium, because we're looking at the subscripts. Okay, that's what's going to tell us. We don't have coefficients yet. That's what we're going to put in there to balance everything out. But we can't change the subscripts right now, so we're just, or later. So that's how we tell that we're going to have it. Now oxygen, I have 1 on this side. Now I do have 1 right here, 4 more right there, but that's tied up with these ones right there. So we're not going to worry about that. Now hydrogen, I have 1 hydrogen there, and I have 2 more over there. So that's a total of 3 hydrogens. And if I go to my sulfate, I only have 1. So I only have 1 sulfate. I would know if I had more than 1 sulfate if I had parentheses around my polyatomic ion. So let's go over to the other side. I have 2 sodiums right there. Excuse me. The number of oxygen I have is 1 oxygen. Again, there's some over there, but that's tied up in that sodium. So we're going to put a 1 right there. Hydrogens, we have 2 here. I do not have any more, so we have 2, which is a good thing. And when I go to my sulfate, we have 1 on each side. So my sulfate's good. We're going to save water to the end, because I always like to save water, because as long as it's in a 2-to-1 ratio, we're going to be good. And when I say 2-to-1, I mean, see, this is 2-to-1. So as long as this over here is in that same ratio, we can adjust our water to whatever we have to. So we're going to start out with sodium. So I have 1 sodium on this side, 2 on this side. So we're going to have to change. Now we can only change the coefficients. So we're going to put a 2 there. That means I have 2 sodiums on that side. So my sodium's good. But because I put the 2 here, everything after it also doubles. So oxygens, instead of having 1, I have 2. And we're going to go ahead and get rid of these. And this. Okay, we'll pull this back. And that also changes the number of hydrogens I have. So I have 1 hydrogen 2 times plus these 2 over here, so my hydrogen is 4. Again, good thing, because now I have a 2-to-1 ratio. So now we're going to go ahead and change the water, and we're going to change it all at once. I can change either the hydrogen or the oxygen. So let's change the hydrogen. I'm going to chase that one across. I have 2 on this side. The only place that I can change it is right there. So I'm going to put up a 2 right there. So now I have 2 times 2 is 4. So now I have 4, but we'll get rid of this. It also changed my oxygen. So I have 1 oxygen 2 times. So now I have, we'll put that right there. We're going to have 2 there. And we'll get rid of this. So if it looks like I have 2, 2, 2, 2, 4, 4, 1, 1, looks good. Let's double check the question again. And again, you always want to double check, triple check, whatever you need to. So I have 2 sodiums here, and I have 2 sodiums here. Okay, I have 2 oxygens here with this 2, and I have same thing with this right there. I have 2 oxygen on this side. I have sodium or hydrogen. I have 2 here on this side because of this, and I have 2 right there. That's my 4, and over here 2 times 2 is 4. And my sulfate, since there's no parentheses on either side and no coefficients in front, we have 1 of those on each side. So I have 1 sulfate on this side and 1 sulfate on this side. So there we go. There's what it is. So our molar ratio is going to be 2 to 1 to 2 to 1. Go ahead and make that nice bright color, and there's our molar ratio. So now we know what our molar ratio is. So what do we do next? Well, we have to start our stoichiometry. Okay, so now I have my molar ratio. I can do my molar mass, my molar ratio, my molar mass to go from grams of sodium hydroxide to grams of sodium sulfate. So we're going to start off with the number that we have in the problem, and that's 200 grams of sodium hydroxide. So we're going to come down here, and we're going to put down 200 grams of sodium hydroxide. And then we're going to put our times. And again, if I went back to my stoichiometry map, my stoichiometry map says, let me drag that down. Right there it was. Go back to it. That we're going to put moles on top and our molar mass in grams on bottom. Then we're going to put our molar ratio. Then we're going to do just the opposite by putting our 1 mole on bottom equals the molar mass. Now these equal each other. Now again, this will equal this in that equation and only in that equation. So make sure that you're not just putting those numbers that you have. It's whatever those coefficients are in that balanced chemical equation. And as long as it's balanced, they do equal each other. So let's go back to the question. So we're going to put 1 mole on the top, and that's going to be of sodium hydroxide. And on the bottom, we're going to put the molar mass of sodium hydroxide. Now, the molar mass can be calculated, I want to get rid of this, by saying I have 1 sodium, 1 oxygen, 1 hydrogen. Now, sodium is 23. We're going to add that to our 1 oxygen, which was 16. We're going to add that to our 1 hydrogen, which is 1. Those total are going to be 40. So we're going to put 40 in right here. So this will be 40 grams of NaOH. Okay, now that we've got it from grams to moles, because these are going to cancel out, so I can cancel this out right now and cancel this on the bottom out. Now we're going to use our molar ratio, and our molar ratio is going to be moles of what we have up here on the bottom. But where do we get that ratio from? We get it from the balanced chemical equation. So we're going to put 2 moles. I have 2 moles of sodium hydroxide, so we're going to go on the bottom over here, and we're going to put down 2 moles of NaOH, and I'm going to take that off right now. But what I'm going to do here is I'm going to underline this, and we'll underline this. Now again, what do we go as on top? Well, we're trying to look for moles of sodium sulfate. So there's no number right there, so that means there's only 1 of them. So we're going to put 1 mole of Na2SO4, so sodium sulfate. Okay, and then we'll put our times in line, because now we have to go from moles to grams. Before we do that, I'm going to go ahead and underline this, and then I'm going to go ahead and get rid of something. I get rid of moles of sodium hydroxide. Same thing over there, because I have it on top and bottom, and it's a good way to check to make sure we have which one's on top, because I can't cancel them out if they're both on top or if they're both on bottom. So now we have to go use our molar mass, and that always equals 1 mole. And since I have moles of this on top, okay, we're going to put that on bottom. So that's going to equal our mole. So we have 1 mole of Na2SO4, okay, and that's 1 mole. Okay, so how much, you can figure out how much it weighs. So 1 mole weighs how much? And that's where we're going to put on top. So we're looking for our grams of Na2SO4. Then overall, we're going to have an equal sign there. So we have to figure out how much this weighs. Okay, now I would like you to just go ahead and show your work, but we're going to go ahead and go past that a little bit. So we know that we have sodium, 2 sodiums. So we're going to add those 2 together. We have 1 sulfur, which is 32. And we have 4 oxygen, which is total together 64. So that's going to be 142. So we're going to put 142 right there. Now let's double check that, and we can do that. So we're going to have 23 plus 23 plus 32 plus 64 equals 142. Okay, so now we have that, and we're going to go ahead and get rid of a couple things. So we can get rid of this because I have it on top and bottom. So I have moles of Na2SO4, and we'll get rid of that. And we're going to underline this. And we know that our final answer is going to be grams of Na2SO4. So that's the only thing that we have left over, right? So that was what we have over there. It's what the question was asking for, how many grams of sodium sulfate. So I have sodium sulfate. And so all I really have to do is the math. So let's go ahead and get rid of this and do our math. Remember, we're going to multiply by the top, divide by the bottom. So we're going to take, and we don't have to worry about our ones, because again, when we multiply or divide by 1, it doesn't affect our answer. So we're going to start off with our 200, and we're going to divide that by 40. Then we're going to divide that by 2 right here, and then we're going to multiply that by 142, and we're equal with 355. So our answer is going to be 355 grams of Na2SO4. Now we have to look at this. Is that our final answer? Well, our final answer needs to be in how many significant figures. We go back to the original problem, and here's our number, and those are one number with zeros. So we have to say, are the zeros significant? Well, our rule states, if we look at our packet, that trailing zeros are only significant if there's a decimal in the number. So there is a decimal in the number, so that means we have to have 4 significant figures. We're going after the problem. I only have 3. So I have to put a 0, but if I put a decimal and a 0, then that's what it's going to equal right there. There we go. So we have our complete answer already right there. So it's going to be 355.0 grams of sodium sodium sulfate. So what do we do with this? We have to go ahead and highlight it because we want to get rid of or highlight our final answer. And that's it. We're all done. We answered that question. So we answered question number 1 from practice sheet number 5. And hopefully we're getting the hang of this. We got a few more practice sheets. We're almost done before our assessment. So keep with it. Keep showing your work and keep up the good work. Hey, as always, go Mohawks. Nelson out.